Section 8.2.1 Spoofing and Sniffing Part 2. Eavesdropping on a network used to be really easy. All you had to do was plug into a hub and you were good to go, because hubs forward all messages to all connected devices. Now that we use switches, it is a bit harder to sniff a network because switches will only forward messages to the MAC address of the intended receiver. To get around this block, the malicious actor must find a way to spoof this address. This is possible by abusing the ARP protocol through ARP poisoning. ARP poisoning can result in an adversary in the middle attack, or AITM. Sniffing or eavesdropping is the object of ARP poisoning, which is to capture messages between two devices on the network. Note that this attack only works in a local area network, or LAN, because it relies on packets being delivered based on their MAC addresses. Remember that a switch connects devices in a LAN, and it uses only the MAC address to make deliveries. If the malicious actor wanted to eavesdrop on messages between devices on different networks, this ARP poison technique wouldn't work because it takes a router to move packages between LANs, and the routers rely on IP addresses to make delivery decisions. Here we see ARP, or ARP, working normally. Bob's computer sends out a broadcast ARP request for the MAC address that belongs to 10.0.0.1. Tanya's computer replies that she is 10.0.0.1 and provides her MAC address. Bob's computer stores the matching IP and MAC addresses in his ARP cache to make future communications faster. Now we see the ARP messages being used for an attack. The malicious actor sends out an ARP reply to let one target on the network know that his MAC address should be associated with 10.0.0.1. And then the actor sends out another ARP reply on the network that his MAC address should be associated with 10.0.0.3. Even though they never asked the question, Bob and Tanya's computers will update their ARP caches with the new information. Stateless means that it doesn't need to do things in a certain order and doesn't keep track of any previous events. So the normal order of business is for someone to make an ARP request and then there is an ARP reply. But since ARP is stateless, it is fine with just getting replies it never asked for. Gratuitous is uncalled for. This is lacking good reason or unwarranted. No one asked for this information, so why did we get a reply? In effect, the attacker has just misrepresented themselves to the two targets so that each will send their packets to the malicious actor instead of sending the packets to each other. The malicious actor has poisoned Bob and Tanya's ARP caches. This is the basis for an adversary in the middle attack. Using ARP poisoning, the attacker will be able to intercept all messages between the two victim devices or an adversary in the middle attack. This type of attack has typically been known as a man-in-the-middle attack. However, the cybersecurity industry is moving towards using inclusive language, and AITM is a recommended replacement term. A version of this attack is used on mobile devices. The adversary in the mobile, or AITMO attack, which was previously known as the man-in-the-mobile attack, is used to take control over a user's mobile device. When infected, the mobile device is instructed to grab user-sensitive information and send it to the attackers. Zeus is one example of a malware package with adversary in the mobile capabilities. It allows attackers to quietly capture two-step verification SMS messages sent to the user.